All right, we're moving on to the next section, section 3.2, vector and scalar quantities. That should be a short section, basically definitions. And let's go on to the next. Let's just read the slide here. A scalar quantity is completely specified by a single value with an appropriate unit and has no direction. A vector quantity is completely specified by a number with an appropriate unit, the magnitude of the vector, plus a direction. So, some examples: a scalar quantity, temperature, mass, time. Those are scalar quantities. They're just numbers. There is no direction. Now, all the ones that I mean, mass and time are both, they can only have positive quantities. There is no such thing as negative mass or negative time. And whereas temperature, well, you can't, if you're not on the Kelvin scale. Kelvin scale starts at 0, but if you're on the Celsius scale or even the Fahrenheit scale, which we won't use much this semester, but if you're on the Celsius scale, you can't have negative temperature. It is a scalar quantity, but it can be negative. A vector quantity is completely specified by a number and a direction. So you know, as I gave my example, if I were flying to Albuquerque, I would need a distance that I'd have to travel and a heading. That is a vector. So vector quantities have both a magnitude and a direction. So let's go on to the next slide. Okay, we have a displacement vector. If a particle travels from A to B, it has a displacement. You remember, displacement is if a runner is running around a track and he ends at the same place that he started, he has a displacement of 0. Now his distance is whatever, 400 meters or something like that, but his displacement is 0. So from A to B is how far an object has traveled and in what direction it went. Now, notice the little squirrely line on the displacement vector slide. It doesn't matter how the particle got there. If it goes along the squiggly line and loops and ends up at B, it's still a displacement vector represented by A and B. So the path doesn't matter. It's where it started and where it ends. That's the displacement vector. Okay, now given that information, let's do a little quiz. This should be simple. Which of the following are vector quantities and which are scalar quantities? Your age, acceleration, velocity, speed, and mass. I'll give you a little time to think about it. Your age, acceleration, velocity, speed, and mass. Well, there's only 2 vectors here, and it's acceleration and velocity. Your age, the speed, and mass are all scalar quantities. Okay, so that is a short little section. That ends our discussion of vector and scalar quantities. The next section will be 3.3, basic vector arithmetic.